All right, so we've got the breadboard plugged in with the battery. Okay, the battery plugged in the breadboard. We have this LED. I want you to take the positive side of the LED, the longer leg, put it in the positive power, and I want you to bring out the negative leg of the LED to any hole, doesn't matter. The important part is afterwards, how you set this up. So, the two legs here of two different resistors are in the same row as the negative side of the LED. The other side of the resistors are in the same row here again. On this side, we have the negative leg of the LED connected to the same row. 1, 2, 3, 4 things are connected right here. This resistor has one leg in here. The other leg ends here in this row 35, 36, where this leg and this leg are physically connected. And then you move down here. This is the last leg. Now, I've taken this wire and put it into ground. Okay, the negative side. Now if I touch this to the LED, to the negative leg of the LED, it turns on. It's pretty bright. Let's see what happens when I have two resistors, one after the other, in series. Let's touch this to this leg. Wow, look at that. That's not bright at all. Okay, now let's try putting it over here. Let's see what happens. Oh, that's brighter. Yeah. Look at that. Versus much brighter. Not as bright as this. That's really bright. So the resistor resists electricity. Now, this is resisting in series, and this is resisting one right next to each other in parallel. Like cars on a freeway, they're right next to each other. The cars over here, they're in front of each other or behind each other. So, the electricity in parallel, the electricity allowed through is more. Let's see. So 1 and 2, right? So we have one resistor, two resistor. This is R1, R2. They're physically connected here, and we're physically connected here as well. So, if R1 is 100 ohms and R2 is 100 ohms, when my electron comes over and has to choose which way it's going to go, it has two choices. So for this equation, we can essentially say 100 ohms divided by 2 equals 50 ohms, right? So this is parallel. Let's look at series. So resistor 1, resistor 2, R1, R2. So for this one, the electricity, the electron, doesn't get any choice. It has to go through this one and through this one to get to the end. Let's look at what happens here. So R1, okay, is 100 ohms plus 100 ohms for R2. Now this is 200 ohms based on the equations. So this equation, you divide by 2, because there's 2 resistors here. I'll show you the equation later. But that's only 50 ohms, whereas this is 200. It's a very, very big difference. So let's look at the equations really quick. So resistor total, this is total series, okay, equals R1 plus R2. Resistor total parallel equals sorry, 1 over resistor total parallel equals 1 over R1 plus 1 over R2. That's why there's division. All right, see if you can make the circuit.